myself, Brad Patel, working as an assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now consider the unit number 8, string matching. In string matching, we already discussed the two methods. Now consider the next two methods in this video lecture: string matching with finite automata and string matching with KMP algorithm. Here consider the outline for today's video lecture is these two technique. First is finite automata and second one is KMP algorithm. Now consider the first method as a string matching using finite automata method. So here what is the finite automata? First understand finite automata. Finite automata M is a 5 tuples Q, Q0, A, sigma and delta. Here consider the capital Q means finite set of states. Now consider the Q0 belongs to Q means Q0 is your starting state and starting state is belongs to your set of states. Now third, consider A belongs to Q means consider the A as your accepting state or answer state. Now consider the sigma. Sigma is a finite input alphabets or consider the input output symbols. And last one is a delta. Delta is a transition function of your finite automata M. So here consider one figure as a finite automata and that finite automata contain the one table. So here second consider as your table or input output table. Now here consider the one by one process or one by one step for these 5 elements. First is Q. Q means set of state. For this figure or for this finite automata, consider the set of state as a state 0 and state 1. So Q equal to 0, 1. Now consider Q0. Q0 means initial state or starting state. So here consider the starting state as a 0. So Q0 equal to 0. Now capital A consider as a accepting state. So here final state in black color consider as a accepting state or final state. So consider capital A equal to 1 because 1 consider as your final state. And here consider the sigma. Sigma means input output symbol. So here consider the A and B as a input or output for the two nodes 0 and 1. So here consider sigma equal to AB. And consider the delta is a function like, for example, consider delta 1b equal to 0 means here consider the delta function for find the output for your given node. So here consider 1 as a node number and b consider as a output. So here delta 1b means b output of node 1 is considered as a 0. So see in this FA, here consider the 1 as a node, B output of one node move to the node number 0. So consider this is your function. Now according to your FA, you can represent the finite automata using the one transition table. So here consider this is a transition table. In transition table, number of row consider as a number of node. So here 0 and 1 consider as a node. Now column consider as a input. So here consider input as a and B. So column as a and B. Now 0 A first block consider as a 0 as a row and A as a column. So here consider the A output of 0 node move to the node number 1. For the B column consider 0 output for the B output for the 0 node consider as a 0. So this is considered as a finite automata. Now consider the suffix of a string. So here consider a one string and for that string consider the suffix which consider as a suffix for your string. If a string W is a suffix of a string X, then it is denoted by W is a suffix of X like this. So this symbol used for the representation of suffix. Now consider one string P equal to ABABA and for this string find the suffix one by one. So here first consider the first character P1 equal to A. So here consider A as a suffix. Now consider the next suffix as a last two elements. So here suffix means pairing of your element from the last location to first location. So consider the one as your first one, consider last A as your suffix. Then BA, last two element consider as a suffix. Next consider last three element, means ABA as suffix. Next last four element means BABA consider as a suffix. So here P1, P2, P3, P4 all the consider as a suffix, and each and every suffix is considered as a P1 is suffix of P, P2 suffix of P, P3 suffix of P, and P4 suffix of P. Now consider the whole string as a P, and then consider P is a suffix of P. Now consider the algorithm for the finite automata technique. So here first algorithm is compute transition function algorithm. So this algorithm used for design the finite automata. How we can find the each and every output of your node. So for example, consider one pattern. Pattern equal to ABABACA means total 7 element. So for this 7 element, consider the number of node as a 0 to 7, and for the 0 to 7 node, find the output as a, here consider the output symbol as a B and C. So find the output of each and every node output as a B and C using this algorithm. So for designing of finite automata, we can use this algorithm. Now consider compute transition function P sigma. Here m equal to length of P, P consider as a pattern. So here m means length of your pattern. For q equal to 0 to m means q consider as your node. So here node starting from node number 0 to ending with the node number m. So in this example, consider the number of node as a node number 0 to node number 7. Now next, for each character alpha belongs to sigma 2, k equal to minimum of m plus 1 q plus 2. Here consider the each character alpha belongs to sigma, means here consider sigma means set of input or output symbols. So here input and output symbol consider as a B and C, because in this given pattern we have a three characters. So A, B and C consider as a sigma. So alpha consider as a B and C one by one. So after that find the k equal to minimum of m plus 1 and q plus 2. M plus 1 means value of m equal to your length of pattern. So 7 plus 1 8, and q plus 2 initially q equal to 0. So 0 plus 2 equal to 2. Now repeat k equal to k minus 1 until p of k is a suffix of p q alpha. So here consider the suffix function or compare the suffix function and decrement the k until this condition is satisfied. After that consider the delta q alpha equal to k, means here consider q as a state, alpha as an input or output symbol, and consider k as your answer of your delta q alpha. Then finally return the delta function, means you can find the finite automata using this algorithm. Now consider this algorithm for our example and find the one by one step using this algorithm. Consider this is your algorithm. We already discussed this algorithm. Now execute this algorithm and find the value for the each and every node. Now consider q equal to 0 to m. So we can say that our total node equal to node number 0 to node number 7. Total 8 nodes are there. Now find the output as a, B and C, because here three characters are there. So find the 0A, 0B, 0C. Here 0A means A output of the node 0. 0B means B output of the node 0. Like this you can find the value for all the nodes. Now consider one by one value. Initially consider the value of q equal to 0. Q equal to 0 means you want to find the value for node number 0. Now consider w equal to a. W equal to a means consider here w as a input character. So initially consider the character as a, then b, then c. For all the character you find the value of q0, q1, q2 like this. So here consider next k equal to 2. P2 is suffix of P0W according to our equation. Here consider value of k as a minimum of m plus 1 and q plus 2. So m plus 1 and q plus 2 minimum value equal to 2. So k equal to 2. Now consider the equation as a P of K is a suffix of P of Q of W. So here P of K means P of 2, P of W, P of Q means P of 0, and consider as a W as your input. So here consider P2 is a suffix of P0W. So what is the value of P2? Now remember that P2 means in pattern consider first two character as a P2. If here P3 then consider first three character. If P4 then consider first four character. So here P2 means consider first two character of your pattern means AB. AB is suffix of now P0. P0 means no any character from the pattern. P1 means only first character. P2 means first two character. But P0 means no any character. That's why we write the null. So here consider this symbol for the null. And next consider as a W and W equal to A. So consider AB is a suffix of null into A. So here consider this is possible? No, because AB is a not suffix of A. So consider the decrement operation of K according to our this algorithm. So here consider the next value of K equal to 1. So consider P1 is a suffix of P0W. So P1 means only A. A is a suffix of null into A. So here consider A is a suffix of null into A. Yes. Then consider value of K equal to 1 for your particular node 0. So for the node 0, A output consider as a 1 because here value of K consider as your answer for this table. So consider K equal to 1 final answer for the node 0 output A. Now consider the next as a output B for the node number 0, Q equal to 0. For that also consider K equal to 2, then P2 is a suffix of P0W. So P2 equal to AB is suffix of null into B because here W is a B. So consider this is not possible. Now consider decrement of K means K equal to 1. Then consider A is a suffix of null into B, not possible. Then consider K equal to 0. Then consider null is a suffix of null B. Then consider null as a suffix. So we can say that K equal to 0 as our answer for the 0B. So put the value 0 here. Now consider the third as a W equal to C means C output of the node number 0 because for the Q0. So consider value K equal to 2. P2 is a suffix of P0W. So P2 means AB is a suffix of null into C because P0 equal to null and W equal to C. Now AB is a suffix of C? No. Then consider K equal to 1. Then A is a suffix of null into C? No. Then consider K equal to 0. Then null is a suffix of null into C? Yes. So consider K equal to 0 as a final answer for the W equal to C in node number 0. So consider 0C output as a 0. Now same way you can find the value for the each and every node. Consider the node number 1 means K equal to 1. Here for K equal to 1, W equal to A, B and C. Three options are there. So first consider W equal to A. Then first initial value of K equal to 3. So consider P3. P3 means first three character of your pattern. So A, B, A as a your pattern P3. Now consider P1 into W. P1 means first character as a from pattern and W means A. So here A and A as your P1W. So find this or compare this. ABA is a suffix of AA? No. Now decrement K means AB is a suffix of AA? No. Then K equal to 1, A is a suffix of AA? Yes. Then consider K equal to 1 answer for Q1A. Now consider Q1B, Q equal to 1 and W equal to B. So consider starting point as a K equal to 3. So compare ABA is suffix of AB? No. Then AB is a suffix of AB? Yes. Then consider K equal to 2 for the B output of the node number 1. Now for the C, W equal to C. ABA is suffix of AC? No. Then AB is a suffix of AC? No. Then A is a suffix of AC? Yes. Then consider the here if A is a suffix of AC, here no any possible way for the find the suffix as a because here consider in AC only C as a suffix, not A as a suffix. So consider next as a K equal to 0, and for K equal to 0 consider null is a suffix of AC, so consider K equal to 0 because null is a suffix of each and every element. So consider one output as a 0, 1 C equal to 0. Same way you can find the value for node 2. For node 2 consider the WA, Q2 and W equal to A, then consider output as a 3. Then for B output equal to consider as a 0, and for C also consider output as a 0 because K value satisfy with the K equal to 0. Now for the next node, node number 3, find the value of A, B and C. Value of A equal to 1, value of B equal to 4 and value of C equal to 0 at the particular node 3. Same way you can find for the node 4. For node 4, A output equal to 5, B output equal to 0 and C output equal to 0 according to same equation or same algorithm. Now consider the node 5 output as a 1, 4 and 6. Node 6 output as a 7, 0, 0 and node 7 output as a 1, 2, 0. So using this first algorithm, you can find the table of your finite automata, and using this table you can represent your figure as a finite automata using this table. For example, in this table first consider the number of nodes. So here total 8 number of node from 0 to 7. So represent this 8 node. After that consider the 0 node and consider the output as a A, B and C. So here A output of the node 0 equal to 1. So we can say that A output of node 0 move to the node number 1. So in this first step we see that 0 to 1 link and consider as a as a output. Now same way you can represent each and every node. For example, for 2, here consider A output of node 2 equal to 3. So consider 2 to 3 link and represent A as your argument. So consider this as output of the finite automata. Now using the finite automata you want to match your text with your pattern. So for matching purpose you can use the second algorithm, is called the finite automata matcher. So here in this algorithm consider T, delta and M as your argument. So T means text, M means length of the pattern and delta is a function. We already find the delta table here as a transition table. Now N equal to length of T means consider text length as a T. Here consider pattern equal to 1 to 7 location and text equal to 1 to 11. So consider text length N equal to 11. Now initially consider Q equal to 0. Then consider I equal to 1. Because for I equal to 1 to N do the following things. So initially consider I equal to 1. Now one by one process is executed here. Now consider first as a, here in this function, remember this function or execute this function many times. Q equal to delta QTI means Q as a state and TI as a text element. So here TI means initially consider T1. So in text consider the one location as a T1 and value equal to A. So here consider Q as a 0. So consider delta 0 1 because 0 as a Q and Ti equal to T1 and T1 equal to 1 A. So here consider 0 A. In this table consider the location 0 A means A output of the node 0 and value consider as a 1. So change the value of Q. So here consider the value of Q as a 1. Now after that consider the next value of I, increment I. So I equal to 2. Now consider I2, Q equal to 1 means check delta 1 and T of 2. T of 2 means B. So check the 1B, 1 row and B column. So in 1B value equal to 2 as a red shaded line. Now consider the 1B as a 2. So represent or change the value of Q as a 2. Now after the value of q equal to 2, consider the increment operation of I. So I equal to 3. Now find the 2, 3 means here consider 2 as your node and 3 as a text location. So third location text as a in last table. So here consider t of 3 equal to a. Find 2 of a. So in second row column a consider as a 2a and value equal to 3. Now change the value of q equal to 3. Now increment I equal to 4. So find the 3 and text fourth location. Means text fourth location equal to b. So find the 3b and 3b value equal to 4. So consider value q equal to 4. Now increment I. So I equal to 5. Now find 4 and text of 5 location. And text of 5 equal to a. So consider for a. For a means fourth row and a column value equal to 5. So consider q value equal to 5. Now increment I by 1. So here I equal to 6. Now check 5 and text location of 6. Text location of 6 consider as a b. So 5b. 5b consider as a value 4. So change the value of q from 5 to 4. Now increment I equal to 7. So for and text location of 7 means for a. Find the for a and for a location equal to 5 value. So q equal to 5 as a new value. Now increment I by 1 means I equal to 8 and q equal to 5. So text 8th location find with the node number 5. So 5 and text 8th location equal to a. C. Text 8th location equal to C. So consider 5c and 5c value consider as a 6 in this table. So 6 consider as your output for the q. Now increment I. So I equal to 9 and q equal to 6. So find output of the node 6 and consider output as a 9 as your I value means t of 9 equal to a. So 6a and 6a value equal to 7. Now consider here next condition is if q equal to m, then print the pattern occurs with the shift I minus m operation. So here q means 7 and m also consider as a 7 because length of your pattern equal to 7. So 7 equal to 7 condition is satisfied. So we can say that pattern is fine here. So this shaded line consider as your pattern because your pattern starting location defined by I minus m. M means consider as a your length of pattern and I means consider as a 9. So 9 minus 7 consider as your starting location for your pattern. Now consider this is a final figure for the finite automata matching. In this figure last row is represent the value of your find value of state ti. So here 0 initially, then 1, 2, 3, 4, 5, then 4, 5, 6, 7. 7 is match means we can consider this is a final matching pattern and represent this pattern like this. So using finite automata algorithm, your pattern is matched using this figure. Means you can simply say that if the pattern length equal to 7, then match the first 7 character and move into this finite automata. For example, pattern is A, B, A, B, A, C, A. Then first move from 0 to 1, A, then B, then A, then B, then A, then C, then A, like this. So if you reach at your node number 7 and your pattern is complete, then we can say that pattern match with your text at particular location. Now consider the next method of string matching is KMP algorithm. In KMP algorithm, first you want to find the suffix and prefix for the given string. After that, you can compare your text with your pattern. So first understand what is the prefix and what is the suffix. Now first table consider as a suffix table. In suffix table, consider pattern p equal to string. String consider as your given string. Then which consider as your suffix. So suffix find from the last location to first location. So initially consider g as a suffix. Then ng consider as a suffix. then ing as a suffix, then ring as a suffix, then tring as a suffix. So your whole string not consider as a suffix, remaining all string or part of your string consider as your suffix, pairing from the last element to first element. Now consider the prefix table. In prefix table, same way suffix you can find the prefix, but here remember that you are pairing from the first node to last node, means move from the left to right. So here consider first prefix as a s, then next prefix as a st, then next str, then stri, then strin as your prefix. Now after that consider the KMP algorithm prefix and suffix definition. The KMP algorithm depend on the pi function. So first you want to find the value of pi function. For that consider the prefix function as a pi. Now for prefix function pi you can first find the value of prefix and suffix. Means first consider proper prefix. Now what is the proper prefix? Proper prefix means all the characters in a string with one or more cut off the end. Means your string is given as a snap, snape, then you cut the one element or more element from the end, means at the last location, then consider as a prefix. So s, sn, sna, then snap as a prefix. Now consider suffix, proper suffix. In proper suffix, all the character in a string with one or more cut off the beginning, means you are cutting from the beginning of the node or string. So consider this is as a suffix. So here consider a string as a hagrit, then consider suffix as a agrid, grid, rid, id and d. So this is considered as a prefix and suffix. Now in KMP algorithm you remember these two steps. For find the proper pattern from the given string, you perform these two steps. Step number 1 is calculate the prefix function, means pi, and second step is match the pattern with your text. Now consider one example how we can find the longest common prefix and suffix. We already know that what is the prefix and what is the suffix. Now find the longest common suffix, means find the common suffix and maximum length common suffix. So here consider first node. For the first position consider value or string as a only a. Here consider string 1 by 1. So initially for the location 1, for find the value of prefix function pi, consider initially as a only string equal to a. For the string a, consider the prefix and suffix. Now here for the string a, no any prefix or no any suffix, because only string or one character are there. For the one character, if we consider 1, then this is considered as a string, not considered as a prefix or suffix, because in prefix and suffix no whole string are considered. Now consider the next location, location number 2. In location number 2, consider string as a AB, first two character. So here AB as a string. Now find the prefix and suffix of AB. Prefix of AB as a and suffix of AB as a B, because suffix means pairing from the last node and prefix means pairing from the first node and suffix from the pairing from the last node. So here A and B, no any match between these two elements, so consider length of the longest common prefix suffix equal to 0, because no any pattern or no any prefix and suffix is matched. Now consider value is 0. Consider next location as a location 3, means consider string as a ABA, first three character. Now prefix as a AB, suffix as a AB, pairing from the last. Now here first prefix suffix as a AA in both the case. Now next is AB and in second case BA. So first AA is matched in first prefix and suffix. So consider the length of your common prefix suffix pair. So here two possible way are there for prefix and suffix, but common prefix and suffix is only one, and length of this character equal to 1. So consider value equal to 1 in this table. Now consider the next location 4, means text as a AB. Now prefix equal to AB, ABA, suffix equal to B, AB, BAB. Now common prefix and suffix consider as a 0, because here consider two second prefix and suffix means AB. In both the case consider prefix as a AB and suffix as a AB. So consider one suffix prefix is match, but length of this consider as your output. So length of this prefix suffix as a 2, because matching prefix suffix as a AB, and length of character of the node AB string as a 2. So consider value as a 2. Remember this point. Now consider next as a string ABA, BA. For that consider prefix as a AB, ABA, ABA. Suffix as a BA, ABA, then BABA. Now in this case, remember that here two text prefix and suffix are matched. First A match, then ABA are matched. So here consider both the are valid output, but consider the maximum length output. So maximum length prefix suffix pair or common pair as a ABA. So consider the length of this equal to 3. Now for the same way you can find the value for the 6 as a 0 and value for the 7 as a 1. So this is considered as a pi table for the your prefix and suffix value of your given pattern. Now consider another example, and using this example match your text with your pattern. So here consider first character as a. For A no any prefix suffix, so value equal to 0. Then B, second value consider AB as a your text or string, so consider prefix as a, suffix as a B, no any match, so consider 0. Now for the 3 consider ABC as a string, now prefix as a and AB and suffix as a C and BC, no match here, so consider value as a 0. Now for the 4 consider value as a ABCA, first 4 character. Now prefix means AB, ABC. Suffix means CA, BCA. Now here only A is matching, so here consider text length equal to 1. Now next for 5 ABCAB, prefix equal to AB, ABC, ABCA. Suffix means B, AB, CAB, BCAB. So here AB is matched, so length of AB equal to 2, so consider value as a 2. Now for the last location consider ABCABY as a string and prefix equal to AB, ABC, ABCA, ABCAB. Suffix equal to Y, BY, ABY, CABY, BCABY. In this case no any prefix and suffix are matched, so longest common prefix suffix equal to 0. So consider this table as a pi table. Now after the find pi table, your next step is match your pattern with your text. So consider your text as a given text ABXA, BC, ABCA, BY, and your pattern as a same as ABCA, BY. Now you have a value of pi in this second table. Consider 0, 0, 0, 1, 2, 0 like this. Now initially you compare the text with the pattern 1, means here text 1 compare with the pattern 1. So consider A compare with A, both they are same, then compare next 2 location. So here consider next location as a 2 location in text and 2 location in pattern. So match text 2 compare with pattern 2. Here consider B and B, both the text consider as the same, so consider matching is possible. Now compare the next 2 character, means third location of text compare with the third location of your pattern. So your next step is text 3 compare with the pattern 3. Now here consider the location of I as a text and location of J as a your second pattern table. So here consider third location of text as a X value and third location of the pattern as a C value. So X not equal to C. That's why we can say that pattern 3 does not match with the text 3. So next comparison is pattern 1 with text 3. How we can find the next comparison? For that we can consider the second table, prefix table and pattern table. In pattern table find the value of prefix function pi. So here consider the last match position in pattern. Remember this point. Here consider the last match position of your pattern is equal to 2 because third location is not matched. Last match equal to 2. So here consider the value of pi of 2 and pi of 2 value equal to 0. So add one value of the your previous match pi value. So 0 plus 1 equal to 1. So this location consider as your pattern next location and text next location consider as it is text 3. So here consider next comparison as a pattern 1 compare with the text 3. Now consider this two location as your next location 3 and 3. Now here x and in pattern as a. So x and a not match. So consider this is not possible. So we can consider this value as a 0 and 0 plus 1 equal to 1 because here pi function value equal to 0. So 0 plus 1 equal to 1. So next time you can start the pattern matching from the location 1 and consider the text location as a T4. So text for compare with the pattern 1. So for compare with 1 means A compare with A. Now after that consider the 5 compare with 2 means B compare with B. Then C compare with C. Then A compare with A. Until the all the match are possible. So here consider last B compare with B. Now next location is 9 location of text and 6th location of your pattern. So here C compare with Y. Here no C equal to Y is not possible. That's why we consider that your text 9 and pattern 6 not match. So we can say that or we can move to the next step as a compare the pattern 3 with the text 9. Why? Here remember that your pi value of last match character. So in pattern last match character as a B or location 5. So at location 5 find the value of pi function prefix equal to 2. So 2 plus 1 equal to 3. So 3 consider as your next value for the pattern. Means compare the pattern 3 with your next location of the text means text last compare text equal to 8 match text equal to 8 but remaining text equal to 9. So compare the text as it is text number 9 and pattern equal to 3. So compare text 9 compare with the pattern 3. So here A 9 location consider as a C and third location in pattern consider as a C. So here match C with the C. Now remember this point here using the prefix table. Your 7 and 8 location not required for matching because already here value equal to 2 means already 2 characters are matched. So A and B is already matched. That's why we directly compare with the third location C. Now according to this you can next compare 10 with 4, 11 with 5 and 12 with 6 means consider A compare with A, then B compare with B, then Y compare with Y. So here hold the pattern match with your text. So consider last matching is text 12 compare with your pattern 6. So we can say that our pattern is find in particular location from location start to location I means location 7 to location 12. Consider as your pattern using KMP algorithm. Now consider the algorithm for the KMP method. According to this algorithm, you can find the first algorithm for find the prefix table. Means pi table with comparison of prefix and suffix. That's why we can use this algorithm. First m equal to length of p, then pi of 1 equal to initially 0, k equal to initially 0. For q equal to 2 to m, you can find according to this. Now next is while loop. While k greater than 0 and p of k plus 1 not equal to p of q, then k equal to y of k. End of while loop. Now consider next if condition. If p of k plus 1 equal to p of q, then k equal to k plus 1, then pi of q equal to k and return pi. Means using this algorithm you can find the pi table of your pattern. Now consider the second algorithm for KMP match, means matching your text with your pattern using the pi table. KMP matcher T and P, T as a text and P as a pattern. N means length of text, M means length of pattern. Now pi means compute prefix function, P means already we find this function using our previous algorithm. This is considered as a pi table. Now Q equal to 0 means number of character match. Q stores the number of character match. For I equal to 1 to n, scan the text from the left to right. So here consider condition as a while k greater than 0 and p of q plus 1 not equal to t of I, then q equal to t pi of q. So here consider next character does not match. Now next condition, if p of q plus 1 equal to t of I, then q equal to q plus 1 means next character match. So we move to the next character. If q equal to m, then is considered as a pattern match. So print the pattern occurs with the shift I minus m. And finally we can say that q equal to pi of q, look for the next match. So consider this is a final algorithm for find the string matching. Now in today's video lecture, I discuss about the two technique for find the string matching or process for the string matching. First one consider as a KMP algorithm and second consider as a finite automata for string matching. Thank you for watching.